Hello and welcome to Beyond the Stars. Today, we're diving into the world of physics and exploring the laws that change the way we understand the universe. I'm talking about none other than the laws of motion by Sir Isaac Newton. Sir Isaac Newton was an English mathematician, physicist, and astronomer who lived in the 17th century. He is often referred to as one of the greatest scientists in history, and his laws of motion revolutionized our understanding of the natural world. So, what exactly are the laws of motion? In simple terms, they describe the relationship between the motion of objects and the forces acting upon them. These laws have far-reaching applications and are used in a variety of fields, including physics, engineering, and even space exploration. Let's start with the first law, also known as the law of inertia. This law states that an object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity, unless acted upon by an external force. In other words, an object will keep moving in a straight line at a constant speed, unless something else stops it or makes it change direction. Imagine you're sitting in a car that's moving at a constant speed. If the driver suddenly slams on the brakes, you'll feel a force pushing you forward. That's the law of inertia in action. Next up is the second law, which states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In other words, the more force you apply to an object, the greater its acceleration will be. And the more massive an object is, the less it will accelerate for a given force. Let's say you're playing a game of tug-of-war. If your team pulls with a greater force than the other team, your side will start to move. And if your team has more mass than the other team, you'll still move, but at a slower rate. That's the second law in action. Finally, we have the third law, which states that for every action, there is an equal and opposite reaction. In simpler terms, if you push on something, it will push back on you with an equal force. Imagine you're on a trampoline. If you jump on one side, the trampoline will push back on you with an equal force, sending you flying into the air. That's the third law in action. These laws are important in astronomy and physics because they provide a framework for understanding and predicting the motion of objects in the universe. These laws describe the relationship between the motion of objects and the forces acting upon them, which is crucial for understanding the behavior of everything from the smallest subatomic particles to the largest celestial bodies. In astronomy, the laws of motion are used to explain the motion of planets, stars, and galaxies, as well as to understand the dynamics of the solar system. They are also used to calculate the trajectories of spacecraft and to determine the orbits of satellites and other objects in space. In physics, the laws of motion are used to explain a wide range of phenomena, including the behavior of objects in motion, the laws of thermodynamics, and the principles of wave mechanics. They are also used to explain the behavior of fundamental particles and to understand the forces that govern the universe at the smallest and largest scales. However, while the laws of motion by Newton are still considered to be accurate for many everyday situations, they are not able to accurately describe the behavior of objects in strong gravitational fields. In these cases, Einstein's theory of general relativity provides a more accurate explanation of the behavior of objects. Check our last video about this theory. In conclusion, the laws of motion by Sir Isaac Newton represent milestones in our understanding of the universe and have shaped the way we view the world around us. These laws provide a framework for explaining the behavior of objects, from the simplest objects in our everyday lives to the most complex celestial bodies. They have opened up a world of possibilities and have been the driving force behind numerous technological advancements and scientific discoveries. But what makes these laws truly remarkable is their timelessness and universality. Despite being formulated centuries ago, they are still relevant and applicable in our modern world, and their predictions have been confirmed time and time again through experiments and observations. They serve as a testament to the power of human curiosity and the unrelenting pursuit of knowledge. So, let us take a moment to appreciate the significance of these laws and theories and the impact they have had on our understanding of the universe. As we continue to explore the mysteries of the cosmos, who knows what exciting discoveries and advancements await us? The universe truly is a never-ending source of wonder, and the laws of motion and theory of general relativity are just the beginning of our journey beyond the stars.